Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. As far as competitive exams like JEE and NEET are concerned, there is one very important model in the concept of relative velocity, that is rain and man. On a rainy day, how the man observes the rain. So consider the situation where the rain is inclined. The speed of the raindrops is inclined at an angle theta with the vertical. So consider this angle to be theta. And this vector is velocity of raindrops or velocity of rain as seen from ground. So this is VR or VRG. Simply VR, it means velocity of rain as seen from ground with respect to ground. Now if the man is stationary on the ground, if the man doesn't move, he observes rain as it is. He observes rain as VR at an angle theta with the vertical. Simple. Now if man moves at some speed horizontally, then how does man observe rain? With what angle and with what speed raindrops will hit him? So this we are going to analyze using the concept of relative velocity. Let us resolve this vector. So if you resolve the vector into horizontal and vertical components, this is the vertical component of the vector, this is horizontal component, and this would be VR sine theta, and the component vertically down, that is VR cos theta. So I write the vector VR bar, velocity of rain is VR sine theta I cap minus VR cos theta j cap, because cos theta component is directed downwards. So I'll use VR cos theta minus j cap. This is the velocity of the rain as seen from ground. Yeah. Now, velocity of man is 0, then velocity of rain with respect to man. So this is the vector, velocity of rain with respect to man. Vrm bar gives us the description of how man observes rain, velocity of rain as seen by man. Now if velocity of man is 0, then Vrm bar is simply Vr bar minus Vm bar. Vm is 0, then Vrm bar is equal to Vr bar. Velocity of rain as observed by man is equal to velocity of rain as observed from ground, because he is standing still on the ground. Now if the man starts moving with some horizontal velocity Vm, then in that case velocity of man is Vm I cap. Now all I need is velocity of rain as seen by man vector Vrm bar. By the concept of relative velocity, it is Vr bar minus Vm bar. So this is nothing but subtraction of these two vectors. So that is Vr sine theta minus Vm I cap minus Vr cos theta j cap. This is velocity of rain as seen by man. Now this vector has everything to tell us the direction and magnitude of velocity of rain as observed by the moving man. So let us analyze this. So if you analyze this vector, it has got Vr sine theta minus Vm horizontal component and a vertically downward component as Vr cos theta. Observe this Vr vector as seen from ground. The vertical component is same Vr cos theta, but because the man is moving horizontally with the speed Vm, the horizontal component is decreased now. So it is Vr sin theta minus Vm. So what actually happens is this is now the velocity of rain with respect to man vector. It is making some angle alpha which is less than theta. Why alpha is less than theta? Because the horizontal component is decreasing, so the vector is moving towards the vertical component. So initially it is theta. As the man increases his speed, you can clearly observe here, the length of this horizontal component decreases and the resultant velocity, that is VRM vector, if the horizontal component decreases, VRM vector is now, the angle made by this VRM vector with vertical is going on decreasing. As the man increases the speed, the angle made by VRM is decreasing, is going on decreasing. Now the question is there any particular speed that the man should move with so that he experiences rain along the vertical, completely along the vertical, so that he experiences raindrops hitting him perpendicularly on his head? Yes, there is a possibility. That means the angle alpha must be 0. So now this vector, so the magnitude of velocity of rain with respect to man vector is simple. It is under root VR sin theta minus Vm whole square plus VR cos theta whole square. Obviously the magnitude is less than VR. That is obvious because the x component has reduced. Now angle that the man is observing, tan alpha. So what is the tan alpha? So from the figure, tan alpha is the horizontal component by vertical component, VR sin theta minus Vm by VR cos theta. This is the angle of rain as observed by man with the vertical. Now, with what speed the man should move so that he experiences rain completely along the vertical? In that case, alpha should be 0. The way how we work out this problem is, if the man sees the rain or observes the rain completely along the vertical, alpha is 0. You can use tan alpha 0. So VR sin theta minus Vm is 0. That is one way of interpreting this. Second way, VRM vector, velocity of rain as seen by man vector, should not have any x component. It should be completely along vertical. It means the x component is 0, which is again VR sin theta minus Vm is 0. In both ways of interpretation, so I can write that man observes rain along vertical or completely along vertical. If VR sin theta minus Vm is 0 or Vm is equal to VR sin theta. This is the conclusion. Now look at this. If velocity of man is matching the horizontal component of rain's velocity, then the horizontal relative velocity is 0 and man observes only VR cos theta. See, if VR sin theta minus Vm is 0, velocity of rain as observed by man is simply VR cos theta downwards. He is only experiencing this vertical component. So if man runs or moves with a velocity Vm that is equal to VR sin theta, then he observes that raindrops are hitting him vertically. If man has a velocity of VR sin theta, but if he is moving in the opposite direction, then it doesn't work out. So suppose he is moving in opposite direction, then Vm bar is minus Vm I cap. Then Vrm bar would be VR sin theta plus Vm. There is no possibility of the x component being 0. Even though Vm is VR sin theta, if the man moves in the opposite direction of rain's horizontal velocity, then there is no possibility of man experiencing rain along the vertical, because in that case you get VR sin theta plus Vm as the horizontal component, and the angle made by the velocity of rain with respect to man with vertical is more than theta. It is going towards horizontal. It's going towards horizontal, so angle is increasing. It is not coming towards vertical like the previous case. So this is not possible. If he is moving in the opposite direction, then experiencing rain along the vertical is not possible. He has to move along the direction of horizontal component of rain's velocity, and if he has that magnitude equal to VR sin theta, then he is experiencing rain vertically downwards. Let us solve a simple question on this. So a man standing on a road holds his umbrella at 30 degrees with the vertical. So from the given information, when he is simply standing on the road, he is experiencing rain at an angle 30 degrees. So when he is standing still on the road, velocity of the rain with respect to man is simply velocity of the rain with respect to ground. So it is given that velocity of rain is making angle 30 degrees with the vertical to keep the rain away. He throws the umbrella and starts running at 10 km per hour, 10 kmph. He finds that the raindrops are hitting his head vertically. So when he is moving with 10 km per hour, he is observing that the raindrops are hitting his head vertically. The speed of the raindrops with respect to road. So with respect to road is nothing but with respect to ground. So you are supposed to find VR. It is a very simple question. Now you can resolve this velocity VR cos theta. So in the vertical direction it is VR cos 30. In the horizontal direction it is VR sin 30. When he is moving at a speed of 10 km per hour, he is experiencing rain completely along vertical. It means 10 km per hour should be equal to VR sin 30. By simple logic, I'll apply VR sin 30 must be equal to 10 km per hour. So VR into sin 30 is 1 by 2, that is equal to 10. So velocity of rain is 20 km per hour. As simple as this. Simple logic that if he matches his velocity with the horizontal component of rain's velocity, then the horizontal relative velocity is 0 and he is only experiencing the vertical component, that is along the vertical. So this simple is this question, if you understand how to apply the concept of relative velocity perfectly. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.